Okay. So what's the overall strategy? What are we going to try to find, and then what are we going to do with that? Yeah.
We have to use aluminum, the amount of aluminum to find the amount of theoretical yield.
Yeah.
Copper, and then you have to put like the actual X or something.
Yeah.
Over the theoretical yield equals 56.
Yeah. So you know already. That's perfect. Well done. So 56.6 equals.
Where'd you get 56?
That's our percent yield.
Oh yeah.
So it's going to be our actual yield, which we don't know yet, over the theoretical, which we can find. And you said we can find it using this, right? We can turn that into our theoretical yield of copper. And then times 100, should be times 100 right there. That'll get us up to 56.6. So we are going to try to find this. Once we find this, we can put it into this little equation, and we can put this as an x to find the actual. Okay? So that's the overall strategy. This was a tough problem just because you had to think a couple steps ahead here. You had to figure out what you actually had to do to get the actual. So let's do this. Let's make the theoretical up here. What is the theoretical yield going to be? We're going to put this, what's going to go on top?
1 mole.
1 mole. 1 mole of Al,
And then do molar mass of Ale.
which is, what is it? Turns out to be
26.992.
26.92 grams times, and now what do we do over here?
3 moles.
We do 3 moles of copper on top.
Wait, sorry, were you getting this now?
We're getting the 3 moles of copper from our reaction on top, our balanced equation. And then down below, what do we put down below? We put the 2. We put the 2 moles of Al because we got 2 right here. So for every 2 molecules, I'm sorry, 2 atoms of Al, we got 3 atoms of Cu. So we get the 3 to 2 ratio right there.
And also when
Now what?
how do you know when copper goes on the top and aluminum goes on the bottom? So
You know that because you want to convert your aluminum right now. You're converting your aluminum from grams to moles into the moles of copper. You're trying to change the starting amount of aluminum into the final product of copper. So at some point you got to change your grams into moles of aluminum, and then your moles of aluminum into moles of copper, and then moles of copper, and then that's our last step over here, into grams of copper. So the grams of copper are going to go up on top. The mole of copper is going to go down below. What's our grams of copper anyway? 63.456. Is it 546? 546.
and where'd you get that one?
That number is in the periodic table. That's right
That's
underneath
the-
Cu. That's a molar mass of Cu. Yeah. So right here we've got grams of cross off. So our units are not crossed off there. Our moles of Al are crossed off. Our moles of Cu are crossed off. And our final units, final, are going to be grams of Cu. Turns out to be 6.54 grams of Cu. And that is our theoretical yield. That can go right here.
But what is theoretical yield again?
So that's the amount of product you should make in a reaction. And this right here, that's our limiting reactant. So that's going to limit how much product we should make.
And then once you plug in 6.54, you can get your X, which is the actual yield.
That's right. This right here is our actual. That's what it represents. Okay, so I'm just going to plug this in. It's a really simple algebra, but sometimes we make mistakes with algebra, so I'll just do this. 6.54 grams down below times 100.
Would you cross multiply first?
Well, the first thing I like to do is divide by 100 on both sides. So I'm going to divide by 100 over here, divide by 100 over here. So that'll give me 0.566 equals x over 6.54 grams. And now I'm going to multiply both sides by 6.54 grams. 6.54 grams. So this will give me then bottom 3.70 grams. And that's what our actual yield is. That's it.
I'm just confused with like the whole like the first step.
This stuff over here.
Yeah.
So over here, we wanted to turn this into moles of Al, of aluminum, right? We wanted to do that so we could eventually find the grams of our product, which was Cu. So our first step is to turn this into moles of Al, and then to turn those moles of Al into moles of Cu.
So you're doing the limiting reactant
Yes.
first, and then you're right. And then you're doing an extra conversion from moles to grams of the product that you
Right.
want to find. Okay.
That's right. And that gives us our theoretical yield. So whenever you're told, find the theoretical yield, or in other terms, like the product that you should make, that's when you convert your product into grams. Always grams, 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 grams. Grams.
Actually, wait,
Not moles. Grams for theoretical
Have you
yield.
ever, like, on a test, aren't there different ways to ask this type of question?
Yeah, I could say, well, this type up over here, I could say, how much copper should you make? That's it. I could say, given this,
Okay.
how much copper should you make?
With the balance. How do you do
And then that would be.
that? And then,
That's your theoretical yield. How much product
Oh,
you should
and
make.
then, but that's the same thing.
I know, that's what I'm saying. That's another way of
So
saying
you also ask
What's like the
what's the
definition
theoretical
in the
step?
book that we wrote for theoretical yield?
how much product you should make in a reaction.
Are you gonna ask us instead of the theoretical, but for the actual? No, instead of the actual for the theoretical,
Well, I could do that,
and then
but that would be pretty easy.
it will,
I could say something like this problem. I could say, let's suppose that CU's percent yield is 56.6%. Okay, and let's say that the actual yield is, and I just tell you what it is. I could say it's 3.70 grams. So I'll just give that to you.
Okay.
And I could say, well, what is the theoretical yield then?
then you just do oh, then you just
plug it in.
Then you just do the reverse of this. You know this, you don't know that.
and so you don't have to do any of this, just do this.
Exactly, it's a simpler problem.
So you did that to find the theoretical.
That's right. The
What
theoretical yield.
are other like hard questions you could ask like all those?
Yeah, because what do you ever have to change the
Say it again,
format? of the-
Like with all those things, like what's another hard question you could get? Like
I can make this incredibly hard and incredibly long if I said the same thing. I could. If I said the same thing, except I give you two starting reactants and I say, oh my god, which one is I don't even say, I could do that. I could
Which
say,
one is a limiting reactant?
I wouldn't even say that. I could say, given these starting reactants, what's in this percent yield, what is the actual product
And then
made?
you first have to
Oh.
find a limiting reaction.
Yes.
I
Then
feel
you.
like that's gonna be
And then you
much
have to
more quick.
convert it.
Is that gonna be on the test?
So
Yeah, I feel like it is, and it's gonna be like if you get one thing wrong, you get everything else wrong.
it's one of those problems, right? Those are the kinds of problems I like to split up into different parts because it's just
yeah.
what happens is, believe me, I don't want to make you guys get everything wrong. I don't want to make you get anything wrong.
You just
In fact, I want to ask you separate questions so that way you can get at least, if you get something wrong, you at least get some questions right.
If
Okay.
it says
Wait, can we go over like? I feel like you could do this question like it really depends how you multiply given the question. Like it's not like a real format, or is it?
That's right. These are just conversions. So you got to be comfortable converting.
Yeah, that's fine.
Yeah.
So,
So do you want to go through a problem like that?
yeah, but also Al reacts with excess CuSO4. That means
Right.
aluminum.
Aluminum or aluminium, whatever you want to say.
Aluminum is the limiting reaction.
That's right. It's a limiting
How do
reactant.
you know?
Because that phrase.
That one phrase tells you. It's a lot of information for just a few words.
With that word.
Excess means
Well, would you have,
extra.
like,
But
a lot?
if the word wasn't there,
If that word wasn't there, you wouldn't know.
so then.
So let's change this problem just slightly. Okay, I like this because it makes us think on our feet a little bit. Let's suppose instead of just saying the first sentence, I say, well, I'm gonna do this. Oh, should I do that? No, I'll keep that up there. I'm gonna say the problem's a little bit different. The problem, instead of saying start off with 1.85 grams of aluminum, instead I say you start with, make up a number, I don't care. 7.00 grams of aluminum. And how much is CuSO4? You make that up too. Tell me.
3.67 grams.
3.76 grams. and 3.76 grams of CuSO4.
So then you have to find the limiting reaction.
Okay, so that's it as our starting point. Okay, so now this becomes a much more difficult problem because there's more steps. Not because it's more difficult to think through, but just there's more steps. So the first thing we have to do is we have to find now which one of these is a limiting reactant, and then from that, which one of those are, then from that you find the theoretical yield from that limiting reactant, and then you find out, from there you can figure out what the theoretical is, and then finally the actual yield. Yeah.
So really, it's just one extra step.
It's, well,
I mean, it's a big extra step.
it's a huge extra step, yes, but you're right.
Theoretical yield is just grams of product.
Yes, the grams of product. And we're searching for grams of copper.
You start from moles of product.
That's right. So I'm going to erase everything that I think is going to change. That's going to be that. It's going to be that. I'll erase all this down below. Everything else can stay the same. Okay, let's use 7.0 grams of Al. Okay. And let's use 3.76 grams of CuSO4. This is getting a little bit crowded here. Okay, so the first step right now, what I'm doing is I'm actually, I'm going to keep this last step right here. I'm going to make the theoretical yield for both of these reactants, and the smaller one is going to be the one I actually use. Does that make sense? Okay.
It's 24.7.
24.7?
Yeah.
Or are you talking about that?
No, that.
Okay, 24.7. 0.7 grams, and that's going to be of Cu. That's a product. Over here, we need to put in all of our molar masses. So Cu is going to be, oh my god, what is Cu? CuSO4. Cu, what's the molar mass of Cu?
It's 63.46.
Plus sulfur, which is
It's
159.607 grams. That's with 4 oxygens?
Yeah.
Okay, good. So that's 1 mole of CuSO4. Pauline, are you following along with this? I want to make sure you get all this stuff down just to be sure.
But then can't you just first find the limiting reactant out of the two and then do that one conversion?
Well, the limiting reactant is going to stop right here after this step. So you could do the final step already, just since you already have it in your calculator for both of them. That's my point.
But then,
So right here,
how do you know that it's the limiting reactant then? If you, as it,
whichever one's smaller.
So the smallest one
Yeah,
is the one that's the
yeah. So right here, what's going to go on the top, what's going to go on the bottom? On the top, it's going to still be 3 moles of Cu. And then on the bottom, it's going to be 3. So it's really times 1 moles of CuSO4. And this is going to be 63.546. Oh my god, over 1 mole of Cu. What's this? This is interesting. 3.6, 3.76 divided by 159.607 times 3 over 3 times 63.546, and you get, we get such a small number. Look at that.
So then that one would be the limit.
1.97, so that's going to be rounded to 3 6 big. That's going to be